In 1981, the world watched as a streak of orange thundered out of Paris and into history. The TGV, Train à Grande Vitesse, wasn't just fast, it was a statement that trains weren't dead, that Europe could outpace the jet age, and that engineering could be beautiful. But here's the thing most people don't realize. The race for high-speed supremacy wasn't just about speed. It was a continent-wide duel of pride, innovation, and sheer willpower, one that would transform travel forever. Before the TGV screamed across France at 186 miles per hour, train travel in Europe was dying. Airlines were taking over. Cars were everywhere. The railways, those grand Victorian networks that once connected empires, were becoming obsolete. Journey times hadn't improved in decades. Comfort was mediocre at best. And young people? They weren't riding trains. They were booking cheap flights or hitting the highways. But a small group of French engineers had a different vision. What if trains could compete with planes, not just on price, but on speed and convenience? What if you could board a train in the center of Paris and arrive in the center of Lyon faster than flying, once you factored in airport security delays and the journey to and from the airport? It sounded impossible, but the French were about to prove everyone wrong, and in doing so, they'd spark a high-speed revolution that would transform Europe and inspire the world. But here's the twist. Building the world's first true high-speed railway network wasn't just an engineering challenge, it was a political minefield, and the obstacles the French faced nearly killed the project before it ever left the station. The story begins in the 1960s. Japan had just unveiled the Shinkansen, the bullet train, connecting Tokyo and Osaka at speeds reaching 130 miles per hour. It was a sensation. Suddenly, high-speed rail wasn't science fiction, it was real. And the French were paying attention. French National Railways, SNCF, started experimenting. They modified existing trains, tested new technologies, and pushed conventional rail to its limits. In 1955, they'd already set a world record with a modified electric locomotive reaching 205 miles per hour. But that was a one-off stunt. They needed something sustainable, something that could run every day, carrying hundreds of passengers without tearing up the tracks. The breakthrough came with a radical idea. Don't modify old trains for old tracks. Build entirely new trains for entirely new tracks. Purpose-built infrastructure designed from scratch for high-speed operation. Dedicated lines with gentle curves, minimal grade crossings, and tracks that could handle sustained speeds over 150 miles per hour. But building hundreds of miles of new railway through the French countryside, that required money, lots of it, and political will, even more of it. The French government debated for years. Critics said it was a waste of money, that airlines and highways were the future, that trains were relics of the past. But in 1976, President Valéry Giscard d'Estaing made the call. France would build the TGV, and it would be the fastest train in the world. Construction began on the Paris-Lyon line in 1976. It took 5 years and cost billions of francs. Engineers had to solve problems that had never been solved before. How do you build tracks that won't deform under the stress of trains passing at 186 miles per hour? How do you design a train that's aerodynamic enough to cut through air resistance, but stable enough not to derail on curves? The answer was innovation at every level. The tracks used continuously welded rail, eliminating the clickety-clack of traditional rail joints. The trains used articulated bogies, sharing wheel sets between cars to reduce weight and improve stability. And the power, all electric, overhead catenary wires delivering 25,000 volts to power the locomotives. On September 27, 1981, the TGV entered commercial service. The Paris-Lyon journey, which previously took 3 hours and 45 minutes, now took just 2 hours. Passengers were stunned. The ride was smooth, quiet, fast. You could set a glass of wine on the table and it wouldn't spill, even at 160 miles per hour. Within a year, the TGV was carrying millions of passengers. Airlines started cancelling flights on the Paris-Lyon route. They couldn't compete. The TGV was faster, more convenient, and more comfortable. The French had done it. They'd made trains cool again. But the story doesn't end there. Because once France proved high-speed rail worked, every other country in Europe wanted in on the action. Germany was watching, and Germany wasn't about to let France dominate high-speed rail. The Germans had their own plans, but they took a different approach. While the French built dedicated high-speed lines, the Germans wanted flexibility. They wanted trains that could run on both new high-speed tracks and existing conventional lines. Trains that could serve more cities without requiring entirely new infrastructure everywhere. Enter the ICE, Intercity Express. Germany's answer to the TGV development began in the 1980s, and the first ICE trains entered service in 1991, connecting Hamburg and Munich. The ICE was sleek, modern, and distinctly German. Where the TGV was bold and aggressive, the ICE was refined and precise. It featured a distinctive white livery with a red stripe, spacious interiors, and technology that prioritized passenger comfort. The ICE could reach speeds of 174 miles per hour, slightly slower than the TGV, but it had an ace up its sleeve: versatility. ICE trains could seamlessly transition from high-speed lines to conventional tracks, serving smaller cities that didn't have dedicated high-speed infrastructure. This made the network more accessible and more practical for Germany's decentralized geography. But Germany didn't stop there. They kept innovating. The ICE3, introduced in 2000, was a game-changer. It featured distributed traction, meaning the motors were spread throughout the train rather than concentrated in locomotives at each end. This reduced weight, improved acceleration, and allowed for even higher speeds. The ICE3 could hit 205 miles per hour and became the backbone of Germany's high-speed network. Today, the ICE network connects every major German city and extends into neighboring countries like Austria, Switzerland, Belgium, and the Netherlands. It's a testament to German engineering and a different philosophy of high-speed rail. Not just speed for speed's sake, but speed integrated into a comprehensive, flexible network. Now, while France and Germany were duking it out for high-speed supremacy, the rest of Europe was taking notes. Spain, Italy, Belgium, the UK, everyone wanted high-speed trains, but each country faced unique challenges and developed unique solutions. Spain's entry into high-speed rail is one of the most remarkable success stories. In the 1980s, Spain's railway network was a mess. Much of it still used a different track gauge than the rest of Europe, a legacy of 19th century isolationism. Journey times were slow, reliability was poor. Spain needed a complete overhaul. So they went big, really big. In 1992, Spain unveiled the AVE, Alta Velocidad Española, connecting Madrid and Seville at speeds up to 186 miles per hour. The timing was perfect. The line opened just in time for the Seville Expo 92, showcasing Spain's modernization to the world. But Spain didn't stop with one line. Over the next 3 decades, Spain built one of the most extensive high-speed rail networks in the world. Today, Spain has over 2,400 miles of high-speed track, second only to China globally. The AVE connects Madrid to Barcelona, Valencia, Malaga, and dozens of other cities. Journey times that once took 6 or 7 hours now take 2 or 3. What makes Spain's network remarkable is the speed of construction and the political commitment. Spain invested heavily using EU funding and national resources to build a network that's now the envy of Europe. The AVE has become a source of national pride, and ridership numbers prove it works. The Madrid-Barcelona route alone carries over 5 million passengers a year. Italy took a different path. Italy's geography is challenging. Mountains, coastlines, and densely populated urban areas make building new railways expensive and complicated. But Italy had an advantage: a strong tradition of railway engineering and a population that loves trains. The Frecciarossa, Italy's flagship high-speed train, entered service in 2008. The name means red arrow, and these trains are fast, really fast. The Frecciarossa 1000, introduced in 2015, can reach speeds of 250 miles per hour making it one of the fastest trains in Europe. The Frecciarossa connects Milan, Rome, Naples, and Venice, cutting journey times dramatically. Milan to Rome, a journey that once took 6 hours, now takes just 3. The trains are stylish, comfortable, and distinctly Italian. Leather seats, restaurant cars, and a level of service that feels more like flying business class than riding a train. But Italy's high-speed network faces challenges. The infrastructure is expensive to maintain, and Italy's economic struggles have limited expansion. Still, the Frecciarossa proves that high-speed rail can work even in geographically challenging countries. Now let's talk about the UK, because Britain's high-speed rail story is complicated. Britain invented railways, the Stockton and Darlington Railway, the Liverpool and Manchester Railway. These were the world's first. British engineering dominated the 19th century, but by the late 20th century, Britain was falling behind. While France, Germany, and Spain were building high-speed networks, Britain was still running trains on Victorian-era infrastructure. Journey times were slow, reliability was poor, and the political will to invest in railways just wasn't there. Then came the Channel Tunnel. In 1994, the Eurostar connected London to Paris and Brussels through the tunnel using French TGV technology. Suddenly, Brits could experience high-speed rail, but only if they were leaving the country. It took until 2003 for Britain to start building its first true high-speed line, High Speed 1, connecting London to the Channel Tunnel. When it opened in 2007, journey times from London to Paris dropped to just 2 hours and 15 minutes. Finally, Britain had high-speed rail. Sort of. The problem? High Speed 1 only covers 68 miles. Once Eurostar trains leave that line, they're back on conventional tracks, crawling through the countryside at 60 miles per hour. It's like putting a Formula One car on a country road. Britain's next project, High Speed 2, or HS2, is supposed to fix this. It's a planned high-speed line connecting London to Birmingham, Manchester, and Leeds. But HS2 has become a political nightmare. Cost overruns, environmental protests, and political infighting have plagued the project. As of 2025, only the first phase is under construction, and even that's years behind schedule. Britain's high-speed rail story is a cautionary tale. It shows that engineering alone isn't enough. You need political will, public support, and the courage to invest in long-term infrastructure. So where does high-speed rail go from here? Because the story isn't over. In fact, it's just getting started. Across Europe, new lines are being planned and built. France is extending the TGV network to more cities. Germany is upgrading the ICE fleet with even faster, more efficient trains. Spain continues to expand the AVE network, and even countries like Poland, Portugal, and the Czech Republic are planning their first high-speed lines. But the real innovation is happening in integration. The future of European high-speed rail isn't just about individual countries building fast trains. It's about connecting those networks into a seamless, continent-wide system. Imagine boarding a train in London, traveling through the Channel Tunnel to Paris, switching to a TGV to Lyon, then connecting to an Italian Frecciarossa to Rome. All on one ticket, all with coordinated schedules, no airports, no security lines, just smooth, fast, comfortable rail travel across an entire continent. That's the vision. And it's closer than you think. The EU is investing billions in cross-border rail connections. New tunnels are being built through the Alps. Old bottlenecks are being eliminated, and booking systems are being integrated so you can plan complex multi-country journeys with a few clicks. But there's another revolution happening: sustainability. High-speed trains are electric. They produce zero direct emissions, and when powered by renewable energy, they're one of the cleanest forms of transportation available. As Europe pushes toward carbon neutrality, high-speed rail is becoming more important than ever. Airlines are feeling the pressure. Short-haul flights, especially routes under 500 miles, are losing passengers to trains. Why fly from Paris to Brussels when the train is faster, cheaper, and better for the environment? Some countries are even banning short-haul flights on routes where high-speed rail is available. The trains are getting faster too. France set a world record in 2007 when a modified TGV reached 357 miles per hour. That's faster than most small planes. While commercial trains don't run that fast, the technology exists. And as infrastructure improves, we could see regular service speeds creeping toward 250 miles per hour or higher. There's also maglev technology, magnetic levitation trains that float above the tracks, eliminating friction and allowing for even higher speeds. Japan and China are already operating maglev lines. Europe is watching closely. Could maglev be the next revolution in European rail? It's possible, but here's the thing. High-speed rail isn't just about technology. It's about connecting people. It's about making it easy to travel from city to city, country to country, without the hassle of airports or the environmental guilt of flying. And it's about preserving something important, the romance of train travel, the ability to watch the landscape roll by, to work, read, or just relax while someone else handles the driving, to arrive in the city center, not some distant airport miles away. High-speed rail connects to something deeper too. Those standard gauge tracks that the TGV, ICE, and AVE run on, they're the same gauge that George Stephenson chose in the 1820s for the world's first railways, 4 feet, 8.5 inches, the same gauge that carried steam locomotives across Europe for over a century. High-speed rail isn't abandoning railway heritage, it's building on it, taking the foundation laid by Victorian engineers and pushing it to limits they never imagined. It's evolution, not revolution. So here's the bottom line. Europe's high-speed rail network is one of the greatest engineering achievements of the modern era. It's transformed how people travel, reduced carbon emissions, and proved that trains aren't relics of the past. They're the future. From the TGV's bold debut in 1981 to the ICE's German precision, from Spain's ambitious AVE network to Italy's stylish Frecciarossa, Europe has shown the world what's possible when you combine engineering excellence with political will. And the best part, you can experience it right now. Book a ticket, ride the TGV from Paris to Marseille, take the ICE from Berlin to Munich, experience the AVE from Madrid to Barcelona. Feel what it's like to travel at 186 miles per hour in comfort and style. So here's my question for you. If you could ride any high-speed train in Europe, which would it be? Are you Team TGV, Team ICE, or are you rooting for the underdog like the Frecciarossa? Drop your answer in the comments below. If you enjoyed this deep dive into Europe's high-speed rail revolution, hit that subscribe button and ring the notification bell. We've got more incredible engineering stories coming your way. Until next time, keep chasing speed.